Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox where I teach you how to become a middle school math master. Today we are looking at percent increase and decrease. I want to let you know, if you haven't already, subscribe to the channel if you're a 7th grade student and you need some help on various different things. But also look in the videos down below because with this lesson in particular, it's really important that you go back and watch my lesson on percent proportions as well, so that you can understand the toolbox that I use for it, which is the percent box. We're going to use the percent box for percent increase and decrease as well. We're just going to use it a little bit different, all right? So I encourage you, if you haven't already watched that video, go back and watch that video so you understand what the percent box is, so that I don't have to spend extra time in this lesson trying to cover it. But again, we're looking at percent increase and decrease, which is just like a regular percent problem. We're going to think of it a little bit different. Instead of thinking about it in terms of part and whole, we're going to use other words like difference and original. But whenever you see a word problem that has the word percent in it, so like this one right here, all right. If it also has the words increase or decrease, you can still use a percent box for that problem. You're just, like I said, you're just going to have to use it a little bit different. Now, other percent problems that you don't use a percent box on would be interest problems. So if you ever see a percent inside of a problem, but you also see the word interest, all right, you're not going to use this method. You're going to use something different. In that video, you'll be able to find that in the video sections down below as well, or underneath my name. So you can go back to my channel. You can find all the videos. Simple interest is going to be another problem involving percent that you'll use a different formula for. But for this one and for all other percent problems, I like to use a percent box, all right, which is just a box separated into 4 equal parts. I always put the clues is percent of inside the corners, the upper left corners, and then a big 100 in that final box right there, because a whole percent is 100%. The problems don't ever tell you that. They expect you to know that. So I always put that 100 right there. All right. In a normal percent problem, we would think of this in terms of part and whole, all right? The top is the part, the bottom is the whole. So you would look for these words is and of inside the problem to try to find, what number would go inside these boxes, all right? The percent sign box always gets a number that has a percent symbol next to it. But the other two boxes are for the part and the whole. So sometimes you find the is and the of, and sometimes you don't. Sometimes they're helpful, sometimes they're not. If they're not helpful, I always tell you to think of this in terms of part over whole, all right? So whatever number is given to you, determine, is that the whole amount that's being given to me or the part of the amount, all right? Well, whenever you see the words increase and decrease, all right, inside the problems, or any other words that kind of point to this idea of something going up or something going down. So words like markup and discount, words like higher and lower, or above and below, or if we're talking about height, taller or shorter, things like that. All those words kind of refer to this idea of something that's moving up or something that's moving down. Now, the hot button words or the key vocabulary words are increase and decrease. All right, so if you ever see those words, we can still use a percent box just like this, but we're going to think of it in terms of difference over original. We're going to talk about what those words mean here in just a second, relevant to math and all that. But instead of thinking about part over whole, we're thinking about difference over original, all right? Difference divided by original, all right? So again, just to reiterate that, if you see the words increase or decrease combined with percent, or you see this words that point to this idea of something moving up or something moving down, that's percent change, and it gets a little bit different treatment than just a regular old percent problem, all right? And the extra treatment is we're thinking of this in terms of difference over original rather than part over whole, all right? Now then, let's just talk about what difference is. Difference in math is an answer to a subtraction problem. So when you have those two numbers that are given to you, like for instance, Mary last year was 40 inches tall. She grew 10 inches this year to be 50 inches tall. What's the percent increase of Mary's height? All right, I think that's an actual problem that we're about to see here in just a second. But you see that she grew by 10 inches because, from 40 to 50, the difference between 40 and 50, her height last year and this year, is 50 minus 40 is 10. So the difference is 10. So whenever you're finding difference, you're just going to be subtracting two numbers. And then that number is going to go on top. All right, inside the top box. And then in the bottom box, you're going to have the original amount. The original is whatever happened chronologically first. All right, what's the original amount? It's the amount that was given to you before anything changed. All right, so it's whatever happened first. All right, so if Mary measured herself last year and she was 40 inches tall, all right, well, that's the original amount. She's 50 this year. She was 40 last year. The original was 40, all right? So original, again, is the amount that in the problem before anything changed, all right? And just as kind of a little bit of help or a little bit of hint, if it's the word decrease, then the original amount is going to be whatever the higher amount is, because decrease means you're starting at a high amount and you're going down, all right? If you see the word increase, you're going to start at the low amount and go up. So if you see the word increase, the original amount is whatever the lower number is, all right? But let's go ahead and get into one of these problems here, and I'll show you how we're going to use the percent box to be able to solve it. By the way, once you get the two boxes filled in, all you have to do to solve it is cross multiply and divide, or multiply the numbers diagonally from each other and then divide by the third number. All right, so let's go ahead and look at this one. Shing just measured himself. This is the exact problem I just gave you. All right, his name's Shing rather than Mary, but here we go. Just measured himself and found out that he's 50 inches tall, all right? The last time he measured, he was 40 inches tall. What's the percent increase for Shing's height, all right? Well, we see the word percent, all right, and I don't see the word interest inside the problem. By the way, interest gets a special formula right here. Again, you can watch, if you are looking for a problem, simple interest kind of explanation, you can find that under my link for all my videos. So you'll be able to find that, the video for simple interest. But if you don't see the word interest inside of a problem that involves percent, then you can use a percent box to be able to find the answer. That's what this looks like right here. And because I see the word increase right here, that's another key word right there, then I know I'm thinking of this in terms of difference over original rather than part over whole. So the difference between Shing's height this year and last year is 10, because 50 minus 40 is 10. All right, and then the original height was whatever happened chronologically first, all right? Not whatever's first inside the problem, all right, but whatever happened chronologically first, or happened first in terms of time, all right? So last year, he was 40 inches tall, all right? That happened before this year, all right? So the original amount is 40, all right? And here we can just, to be able to solve this, now we've got them filled in, we can cross multiply and divide. So all you have to do is do 100 times 10, all right? Because that's these two numbers that are multiplied diagonally, all right? And then we're going to divide by 40, and we're going to get 25%, all right? So he has a 25% increase in height over from last year to this year, all right? Cool. Let's try another one. There we go. What I want you to do is, if you feel comfortable with this, go ahead and pause this and try it yourself, and then come back to see what the answer is. If you feel like you need an extra little help, because I've got about another 3 or 4 problems after this, then you can watch me do this one, and then you can try the next one on your own. All right? So if you want to try it on your own, go ahead and pause it. All right, a computer shop sold 400 computers last month, and 523 computers were sold this month. What's the percentage increase in the sales of computers? Now I see a keyword right here, percent, all right, percentage, all right? And I don't see the word interest in the problem, so now I know I can use a percent box, all right? Is percent of 100, all right? And then I see also another keyword, increase, all right? If there's a regular old percent problem, I would be thinking of it in terms of part over whole, all right? But in this case right here, I see the word increase, so I know I'm thinking of this in terms of difference over original, all right? Now then, the difference between last month and this month is 123 because we subtract the two numbers. 523 minus 400 equals 123. So that's the difference between the two. And then chronologically, which one happened first? Last month it was 400. This month it was 523. So chronologically, 400 is the original amount. All right? Now we've got our numbers placed inside the percent box. We can just simply cross multiply. So 123 times 100, and then we're going to divide by the third number. So divided by 400 equals 30.75%. All right, which is a pretty decent percent increase there. All right, let's try the next one. Go ahead and pause this video now and see if you can try it yourself. All right, see if you can do it all by yourself and then come back and get what the answer is. All right, skis at a sports store near Snow Summit are on sale for $476. If the original price was $560, what percent decrease does this represent? All right, I see the word percent. I don't see the word interest, so I'm going to use a percent box. All right, is percent of 100, just like that. And then I see this keyword decrease. All right, so I know that I'm going to think of this in terms of difference over original, just like that. So the first thing I'm going to have to do is find the difference between 560 minus 476, that's 84. And then the original amount. Well, this problem gave it away, all right? It's like a dead giveaway, okay? If the original price was 560, the original is 560. We really don't even have to think much inside this problem. We just know it's 560. So we have 84 then multiplied by 100 to solve this. And then we're going to divide that by the third number, 560, and we get 15%. All right? That's a 15% decrease. All right, let's try one more. Maybe two more. Okay? The average fine for entering a national, you can pause this if you want to. You can go ahead and try it on your own. All right? Here we go. The average fine for entering a national forest wilderness without a permit increased from $65 to $78. What percent increase is this? Again, we see the word percent, all right? I don't see the word interest, so I can use a percent box. Is percent of 100, all right? And I see this keyword increase, all right? Increase tells me I'm thinking of this in terms of difference over original. So we have 78 minus 65. Quick math tells me that's 13, all right? And then we want to know what our original amount is, okay? Well, if it's increasing, then it's starting low and going high. So the lower amount, 65, is going to be our original. So we're going to take 13 multiplied by 100, and we're going to divide that by 65, and we found out our percent increase is 20%, all right? Just like that. Okay, let's try another one. All right, go ahead and pause this video. Go solve it yourself if you'd like, and then you come back to see what the right answer is, all right? A pair of snow boots at an equipment store in Big Bear that originally cost $60 is on sale for $36. What is the percent decrease, all right? Again, percent box, because we don't see the word interest inside of a problem that involves percent. I see the word decrease, so I'm thinking of it in terms of difference over original. 60 minus 36 would be 24. That's the difference, all right? And the original, it tells us it originally cost $60, all right? And decrease means we're starting high and going low. So we have $60 right there. So we're going to multiply 24 times 100. Those are the numbers that are diagonal from each other. Right? And we're going to divide that by the third number, which is 60. And that's going to give us a 40%. So the decrease is 40% decrease. All right. I hope you enjoyed this video. Hope it helped you out. Leave comments in the comments down below if you have any questions. And I hope you have a great day. Okay, bye-bye.